Hi, today we're looking at Functional Skills Maths Level 2. We've got the AQA specimen paper and we're going to start with the non-calculator section. Question 1. What is 3/5 as a decimal? And they're asking us to circle the answer. Okay, well it's probably easier to think of 3/5 as being 3 divided by 5. Well, if we were doing a division, we would do the bus stop method. And we'd put the 3 on the inside and the 5 on the outside. Okay, but suddenly you're going to see 5 doesn't go into 3. So what we need to do is we need to put a decimal point and zeros. You can put 1 0, you could put a few zeros. It doesn't matter. You can always add more if you need them. So I'll just do 1 for now. So what happens is we say 5 into 3. Well, 5 can't go into 3. So we put 0 and the decimal point in line. But we haven't used the 3, so we have to carry it across. So now we say, well, how many times does 5 go into 30? Well, you got 5, 10, oh, not 5, 10, 5 into 30, yeah, 5, 10, 15, 20, 25, 30. So that's 6 times. So we've got 0.6. So this one here. Okay, question 2. Work out 7 minus 2.835. Right, so I'm going to do this as a column. So we've got 7, and beneath it we're going to put 2.835. Now I've got nothing to take these digits away from, so I'm going to put 0, 0, 0 above. Okay, which will help. So now we start here. So we always start with the right, from the right when we're subtracting. 0 take away 5. Well, we can't do it. We've still got another 0, so we've got nothing to take from. So we keep going all the way along from the 7. And we can say, well, I can reduce the 7 to a 6 and pass 1 over. Okay, but it's over here I need the extra 1. So I can reduce the 10 to a 9 and pass 1 over. Reduce the 10 to a 9, pass 1 over. Now I've got 10 minus 5, which I can do, and I get 5. 9 minus 3 is 6. 9 minus 8 is 1. Bring the decimal point down. And 6 minus 2, we got 4. So we can put our answer in here, 4.165. Okay, question 3. Work out the size of angle X in this triangle. And note it says work out. So we're not going to get our protractor out. We need to do a calculation. Well, I know that the total angles in a triangle are 180 degrees. So if I know what the total of these angles are, I can take them away from 180. So we could do 36 plus 36, or we could do 36 times 2. 6 plus 6 is 12, to carry 1. 3 plus 3 is 6, plus 1 is 7. Okay, so these in total are 72 degrees, so this must make up the rest. So we can now do 180 minus 72 degrees. Okay, so like we did before, we can't take 2 from 0, so we reduce the 8 to a 7 and pass 1 over. So 10 minus 2, we get 8. 7 minus 7 is 0. 1 minus nothing is 1. So we can answer of 108 degrees. Okay. We've got question 4. Plot the point -3, 2 on this grid. Okay, so when we're looking at coordinates, and we've got a set of points like this, we always, the first number always refers to going across the x-axis. So -3, well, that's going to be this way, -3 here. And the second number is 2, so we're going to go up to 2 here. So we can just mark that on with a cross. Question 5. Work out 25 minus 2 times 3 squared. Okay, so we've got to use our order of operations. Well, we use our BIDMAS or BODMAS order. So B stands for brackets, we haven't got any brackets. I is for indices, or O for order of. In other words, it's the 3 squared we've got to do first. Well, I know 3 squared is 9, so I can write that down here. But everything else stays in line. So I've still got 25 minus. I've still got 2 times. But all I've done is replace the 3 squared with the 9. Okay, now we think, well, what comes next? Well, I've done the indices. Next is division. We haven't got any division. The M stands for multiplication. So this is the next bit we need to do. Well, 2 times 9 is 18. But we've still got the 25 minus. So I'm not changing the order of these things. I'm just changing the order in which I do the calculations. So now we've got 25 minus 18. You can write it as a column, or you can start at 25 and count back. Or probably the easiest way to do it is to start from 18 and count up to 25. So we'd have 18, we'd have 19, 20, 21, 22, 23, 24, 25. So that's an extra 7 that's going to take us up there. But as I say, if you wanted, you could do it as a column. 25 minus 18. We can't take the 8 from the 5. So we'd make it 15 minus 8, which gives us 7. And 1 minus 1 is 0. So we'd still get the same answer. Okay, question 6. A, B, C and D are scatter diagrams. Okay, we've got different patterns on here. Which diagram shows negative correlation? Circle your answer below. Well, it's probably easier to explain positive correlation first. What positive correlation means is that as the X values increase, so do the Y values. So something like this would be positive correlation. And again, this would be positive. Negative is the opposite. As the X values increase, the Y values decrease. In other words, you're going to get a downwards slope like this one. So our answer is going to be C. A, well, this doesn't look like they're correlated at all, really, because it doesn't seem to matter if the values go up or down. It's hard to see a pattern. So the 2 key correlations you're looking for are positive, the values are generally going up to the right, or negative, they're going down to the right. Question 7. Market stall. Lisa makes fudge and sells it on a market stall. Okay, Lisa makes fudge using these ingredients. So sugar, 500 grams, butter, 85 grams, evaporated milk, 175 grams, milk, 150 millilitres. No, we've got different units. And flavouring, 20 millilitres. This makes enough fudge for 4 boxes. Lisa wants to make enough fudge for 48 boxes. She already has 1.4 kilograms of sugar. Sugar is sold in 1 kilogram bags. How many bags of sugar does she need to buy? Okay, so we're only really interested in the sugar. Okay, up here. Now, she's got enough for 4 boxes. So we're saying 500 grams makes 4 boxes. We want to get up to 48 boxes. So 2 ways you can do it. I think some people will probably prefer this first method, which says, well, if we got 4 boxes of 500 grams, well, 1 box is going to be 500 divided by 4. Okay, which is fine. And then you can work out how much for 1 box and then multiply it by 48. I'm going to do it slightly differently, which is a bit of a sort of shortcut method. And I'm going to say, well, I'm going to think about it as ratios. So we've got boxes and we've got sugar. Okay, and we're saying for 4 boxes, we need 500 grams of sugar. We want 48 boxes. Okay, well, how many lots of 4 do we need to make 48? Well, let's do it with the bus stop method. So 48 divided by 4. 4 goes into 4 once, and 4 goes into 8. 4, 8. That's twice. So what we're saying is we actually want 12 lots of these 4 boxes. Okay. So if we're multiplying the 4 by 12 to get 48, we could do the same thing to the 500. Okay. Now, instead of, so we want 500 times 12. We can ignore the zeros for now and just say, well, what's 5 times 12? Well, you can do it using the column method, or hopefully, you know, with your mental arithmetic, with your times tables. 5 12s are 60. But then we've got 2 zeros to add back on. So we end up with 6,000. And this is all in grams. Okay. So in total, I'll move this up here. We've got 6,000 grams, but she's already got 1.4 kilograms of sugar. So what way do we want to do this? We've got kilograms there and we've got grams here. Well, actually, I think I'm going to turn this into kilograms. That's going to be tidier. So we've got 1,000 grams in a kilogram. So 6,000 grams, well, that's just 6 lots of this, so it's just going to be 6 kilograms. Okay. Right, so in total we want 6 kilograms. She's already got 1.4 kilograms. So we just need to know how much more do we need. Okay, and it's sold in 1 kilogram boxes. So you could do 6, take away 1.4 and work out your answer. But actually, if we just think, well, if I start with 1.4 kilograms, if I add 1, it's going to take me to 2.4 kilograms. Another one's going to be 3.4, 4.4, 5.4, 6.4. So that's going to take me over the 6 kilograms that I need. And that was by buying 5 more bags of sugar. So we can put down here 5 bags. Okay. It needs to be a round number. So even if you did it this way, you could work this out. You end up with 4.6. But you can't buy 4.6 bags of sugar, so you would still need to round it up to 5 bags. Okay, 7B. Lisa sells the fudge in 3 flavours: strawberry, vanilla and mint. She looks at the number of boxes of each flavour she has sold in the last few weeks. So strawberry, she sold 60. Vanilla, 140 boxes. Mint, 40 boxes. This week, Lisa makes 48 boxes. Using the data above, how many boxes of each flavour should she make? You must show your working. Right, so with the previous question, you didn't have to treat it as a ratio question, but this one, I would say you really should. So I'm going to draw a ratio table. So we're going to have S for strawberry, V for vanilla, M for mint, and we'll have a total column. So every time we've got 60 boxes, we've got 140 vanilla and 40 mint. So if this is all we had, how much would we have in total? Well, you could do it as a column, but actually, hopefully you'll see, well, 60 plus 40 makes 100. And 100 plus 140 gives us 240. Okay, so if this is all we had, we'd have a total of 240. But actually, we're told we've got 48 boxes. Well, if we look at how we're getting from 240 to 48, you might notice, well, actually, if we ignore the 0, 24 to 48, 48 is double 24. So if we think of it as like a process, we're taking off the 0 and then we're doubling the number. So let's do the same with these. Take off the 0, so we've just got 6, and then double it. Gives us 12. Same with vanilla. Take off the 0, so it's like we're dividing by 10 and doubling it, and then times it by 2. So 2 times 14 gives us 28. And the same with mint. Take off the 0, divide by 10, and then double it. 2 times 4 is 8. And we can do a check, because if we do 12 plus 28, 2 plus 8 is 0, carry the 1. 1 plus 2 plus 1 is 4. So we've got 40 plus 8 makes a 48. Okay, so we've got all of the flavours that we need, and it was all by looking for the pattern of getting from this number to this number. So that's why it's really good to be familiar with your times tables and just sort of seeing the relationship between numbers. So now we can put these down at the bottom. So we had 12 for strawberry, 28 for vanilla, and 8 for mint. (7C). Lisa has to drive 50 miles to the market. The market starts at 9 a.m. She needs to arrive at least half an hour before the market starts. She leaves home at 7:10 a.m. Lisa says, if I drive an average of 40 miles per hour, I will be there in time. Is she correct? You must show you're working. So if she needs to arrive at least half an hour before the market starts, well, half an hour before 9 a.m. would be 8:30 a.m. because we've got 30 minutes in half an hour, okay? So she leaves home at 7:10 and she needs to be there by 8:30. Okay, well, so if we think about the difference, well, we're increasing it by 1 hour, and from 10 to 30 is 20 minutes. So basically she's got an hour and 20 minutes to do the journey, and she's driving at an average speed of 40 miles per hour. Okay, so let's think of this. We know that in 1 hour she can travel 40 miles. How far could she travel in the extra 20 minutes? Well, 20 minutes is going to be 20 out of 60, because we're thinking of it in terms of miles per hour. So 20 minutes out of 1 hour is 20 out of 60, which we can cancel the 0. So it's the same as 2 out of 6. They're both even numbers, so we can divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Okay, so we've got a third of an hour. Okay, and if she's travelling at 40 miles per hour, so in 1 hour she travels 40 miles, how far would she travel in a third of a mile? So we want a third of 40. Or in other words, 40 divided by 3. Well, 3 goes into 4 once with 1 remainder. 3 goes into 10, 3, 6, 9. That's 3 times with 1 remainder, so we can put 1 in there. And hopefully you'll see we're doing 3 into 10 again, which is going to be 3 with 1 remainder. So it would just keep on 13.33333. But for the purposes of this question, we could just round this and say round to 13. So what it's telling us is that in an hour and 20 minutes, or in 1 1/3 hour, she can travel 40 miles plus an extra 13 miles. Well, we can just add the tens on, so 4 plus 1 is 5, so that's going to make 53 miles. That's in the time available. She only needs to travel 50 miles. So is she correct? Yes, she can make it in time. We don't know how much time she'd have yet left. We could work that out, but we don't need to. All we need to know is, yes, she can certainly do 50 miles in the time, because we know she could travel 53 miles in the time. And that's the end of the non-calculator section. And now for the calculator section. Question 1. A set of numbers is, and we've got 4, 6, 6, 7, 8, 8, 8, 9. Circle the mode. Well, the mode is the number that occurs most often. Because they've sorted them for us, so actually it's nice and easy to see, well, we've got 2 6s, but we've got 3 8s there. So we've got more 8s than any other number. So that's our mode. Okay, question 2. Work out 9.386 plus 20.904, all divided by 2.5. Give your answer as a decimal. All right, so we've got order of operations, but really when we've got a fraction like this, we sort of treat the top and bottom separately. So it's like there's an invisible to the pair of brackets up here. So even though we've got a division, we have to do this addition before the division because it's all together. Yeah, we can't divide bits separately. We'll do it all as one. Well, you could, but it would just make it messier. So we're going to imagine we've got a pair of brackets around this, and we can use our calculator now. So 9.386 plus 20.904. So this gives us 30.29. And that's then all divided by 2.5. Which gives us 12.116. Which we can write down here. Question 3. The probability of event A happening is 0.15. Work out the probability of event A not happening. Well, the total probabilities of all the outcomes need to add up to 1. So if the probability of it happening is 0.15, the probability of it not happening must be 1 minus 0.15. Again, we can use our calculator to give us 0.85. Okay. Which you could write as 85% if you want, but we might as well leave it as a decimal. Question 4. Circle the calculation that increases £260 by 17%. Okay, increases it by that amount. Well, I'm going to do it by a process of elimination. £260 plus 0.17. Well, 0.17 is 17%, but we want 17% of 260, not just 0.17. This isn't 17% of anything, it's just 17, as a percentage. So it's not going to be that one. 260 times 0.17. Right, well, this is working out 17% of 260. But we don't want just the 17%. We want to increase it by 17%. So really, to make this work, we would want 260 plus 260 times 0.17. That would be correct, but because we haven't got this bit, that doesn't work. 260 plus 1.17. Well, again, we're increasing it by, so we need a multiplication in there. This plus isn't going to do anything. This is just going to 1.17. Well, we can see, 10% of 260 would be 26. Take the 0 off. And this is a lot less than 26, so that's too small. So we're left with this one, but let's work out what it means. 260 times 1.17. Well, if you think 1.17, this is our 17%. The 1 actually means is 117%. And that is exactly what increasing by 17% is. You're taking 100% of the number and you're adding on an extra 17%. So that's what we want. Question 5. Write in digits 403,720. Okay, so 403,000. So 403,000, put a comma, 720. 720. And that's it. But let's put it down in our answer box to be complete. Alright, question 6. Work out 5 3/4 minus 1 1/8. Okay, so often with these, what I like to do is convert the whole number into a mixed number. So the whole number and the fraction bit, so that we take away, so we don't have to do anything messy afterwards. But with this one, I think it's fairly clear that 1/8 is smaller than 3/4. So I'm going to say, well, I know that 5 minus 1 is 4. So I know that the whole number part of my answer is going to be 4. To know what's left of the fraction, we need to do 3/4 minus 1/8. And to work this out, I need my denominators to be the same. Well, I can see, well, 4 goes into 8. In fact, 4 is half of 8. So I want to rewrite this fraction as being over 8. And because it's half, I need 4 times 2 to get me up to 8. Times 2. So I need to do the same to the top. So 3 times 2 is 6. So what we're saying is these are equivalent fractions. 6/8 means exactly the same as 3/4. But it helps me because now I've got the same denominators. So I can keep the 8 as the denominator and just do 6 minus 1 to give me 5. And write that down now. Okay, question 7. A circle of radius 5.2 centimetres is inside a circle with radius 8.3 centimetres. Work out the shaded area. Right, so the shaded area is this bit on the outside. Okay. Now, I don't have a nice simple formula that will work out just the area for me. But I do know that the area of a circle is pi r squared. Now, if you think of this as it's one big circle, but without the smaller circle. So if we work out the area of the big circle, in fact, I'm going to write that down. What we want is, our answer is area big circle minus area of small circle. So we know what it is we're trying to achieve. Well, the area of the big circle is pi. Well, in fact, pi is going to be given to us. So let me. So pi. Well, the radius of the big circle is 8.3, and it's squared, so it means it's multiplied by itself. So now on the front of the paper, it does tell us for pi, and I'm just double checking this, but it should tell us to use 3.14. In fact, I don't think they do. I think they just expect you to know that. So we can rewrite this as 3.14, which is an approximation of pi, but that's any past paper will always allow you to use 3.14 for pi. Then we want it times 8.3, and because it's squared, times itself. So 3.14 times 8.3 times 8.3, 216.3146. Okay, so now we want the area of the small circle. This is what we're going to take away. So it's going to be pi again, which we've already seen we can use as 3.14. And r, in this case, is just 5.2. But it's still squared, so it's times another 5.2. I'm going to put this in my memory later, but if you're not comfortable with using your memory, that's fine. Although you can look at my video of how to use a simple calculator, which will show you that. So 3.14 times 5.2 times another 5.2, and we get 84.9056. 216.316. Well, we want to take that off of 216.3146. In fact, I'm going to be clever here and I'm going to take it away in the memory. So if I do memory recall, we get 131.409. Now, if you're not comfortable with how I did it, I'm going to show you the long way. So, area of shaded area is going to be the area of the big circle, so 216.3146, minus this area of the smaller one, which is 84.9056. Okay, but you'll see, actually I wrote my answer down here before, so if I work this out, it should give me exactly the same answer. Let's clear that. So 216.3146 minus 84.9056. Yeah, exactly the same. Okay. Question 8. Each of the 4 cubes in this L shape has side length 1 centimetre. Okay, so what that means is that is 1 centimetre, that is 1 centimetre, and also the height of one of these is 1 centimetre. On this centimetre grid, draw a plan view of the L shape. Right, well, a plan view means looking straight down on it, like bird's eye view. So if we're looking down on this, we're going to see the top of this one, top of this one, top of that one. So that's all we're going to get. 1, 2, 3. We'll just see it as one rectangle like that. Now, because we've got this sort of extra bit sticking out, what we can do is we can draw an extra line on there to show that there's something going on. We can't tell the height of them, but we know there's like a break, there's something different happening. Question 9. Work out the percentage decrease from 5,200 to 4,108. To find the percentage decrease, first we want the actual decrease. So we get that by doing 5,200 minus 4,108. So 5200 minus 4108 gives us 1,092. So if we want to turn that into a percentage decrease, we take the 1,092, divide it by the number we started with, which is 5,200, and to make it a percentage, we'll multiply it by 100. So 1,092 divided by 5,200 times it by 100, and we've got 21%. Okay. Question 10. Playground. Levi works for a company that designs and builds playgrounds. Here is a sketch of the plan for a new playground. I'm going to move it up so we can see the measurements. Right. So, okay, we've got this space here. We've got 20 metres along, 60 metres up, 7, 5, 5, 7 metres across. So we haven't got all the measurements. We don't know this measurement. We don't know this measurement. Work out the area of the playground. Okay, right. So how are we going to do this? Well, it's not a standard rectangle or any other shape we can easily work out. So what we're going to have to do is split it up. And what I'm going to do is split it up this way. Now, by doing that, I can say, well, I've got a rectangle here. And I know that the area of a rectangle is the length times the width. So I might as well do this now. Well, the length is 20 and the width is 11. So 20 times 11 we've got 220, and that's meters squared. Okay, I've got these two other areas. Let's go with this one because this is another rectangle, so this should be a straightforward one. So length times width, so this time the length is 7, the width is 5. You can use your calculator, but I'm sure you all know that 7 5s are 35. And again, it's meters squared. Now we've got a triangle, okay? And also we've got a triangle and we don't know what this length is. Well, actually, we do, because it's going to be the same as up there. So we've got this is 7 meters. Well, the area of a triangle is similar to that of a rectangle, but if you look, it's basically half, isn't it? It's like a rectangle that we've just put the diagonal on. So, in fact, it is length times width, but it's a half of length times width. And instead of length times width, because it's a triangle, we tend to call it half of the base times the height. But actually, it's the same thing. Okay, so half times base times height. So we've got half. The base is 7, and the height is 5. So half, you can type it in as 0.5, or you can do 1 divided by 2 times 7 times 5, and you get 17.5 meters squared. So if we want the total area, we need to add those all together. So the 220 plus the 35 plus the 17.5. Well, we've already got the 17.5 in, so let's do it backwards. Add the 35 and the 220. We get 272.5, and that's still all in meters squared. In fact, let's put that down here. They've done the units for us, but it's always good to consider and think about what units you are using. Okay, so 10b. The surface of the playground will be covered with rubber chips and resin. Levi uses 14 kilograms of rubber chips per square metre. He also uses resin in the ratio. And we've got the mass of rubber chips to the mass of resin is 5:1. So every time we've got 5 kilos of rubber chips, we've got 1 kilo of resin. The resin is supplied in 25 kilogram tubs. How many tubs does Levi need? Right, well, we need the answer from before to start us off. So if you remember, the total area was 272.5 meters squared. Now, you are at a disadvantage if you haven't worked out the answer to the previous question. However, if you haven't, what I would say is pick any number. Okay? So that way you can at least demonstrate you know the process. Even though this number might not be right, you can still get some workings marks for it. Okay, so what we can do now is say, well, let's draw a ratio table because we've got a ratio given. And what have we got? We've got chips to resin, and we're going to have a total column. So every time we've got 5 lots of chips, we've got 1 of resin. And if that's all we had, well, 5 and 1 gives a total of 6. Okay. Well, let's think about how much rubber he needs altogether, because it tells us Levi uses 14 kilos of rubber chips per square metre. Well, if he's got 272.5 metres, he's going to need 14 kilos for each of these metres. So in other words, we're going to multiply that by 14. That gives us a total of 3,815 kilograms of rubber chips. So we can write that down here. That's the total amount of rubber chips he's going to need. So we want to think about how we're getting from the 5 to the 3,815. What multiplier are we using? So we think of it backwards. We say, well, let's take 3,815 and divide it by 5. And if we do that, we get 763. Okay, so that's saying we need 763 lots of these to get our new row. So resin 1 times 763, well, that's just going to be 763. And for completeness, we might as well do the total. So 763 times 6 gives us a total of 4,578. Although we're not really interested in that, because they're asking us about resin and how many tubs of resin he needs. Okay, so this is the key information. Right, he needs 763 kilograms of resin. It comes in 25 kilo tubs. How many tubs does he need? Well, we need to know 763 divided by 25. So 763 divided by 25. We get 30.52 tubs. Well, you're not going to be able to buy 0.52 of a tub. So we're going to have to go up to the next whole number, which is 31 tubs. Because if we only did 30 tubs, it's not enough. So we've got to go to the next whole number. So we can put that down there. 10C. The table shows the items needed for the playground. So we've got a climbing frame that needs 6 meters by 6 meters. A swing set needs 10 meters by 4 meters. And it's saying that basically 6 by 6 would make a square, 10 by 4 is a rectangle. One sand pit, a semicircle with radius 6 meters. So think of that as, there's our semicircle. There's our radius. And two rockers, 2 of them, each 2 meters by 2 meters square. The playground is drawn to a scale of 1 to 200 on a centimetre grid. On the grid, design a possible playground. Right, and we've got a grid here for us. Okay, but we're going to do some calculations before we start drawing on there. Because on that grid, we know that we've got a scale, and they're telling us that it's centimetres on the grid. Well, at the moment, this is all in metres. So I want to turn this from metres into centimetres. Now, you sort of need to do it twice, which can be a bit confusing, because these are written in metres. So first, I'm just going to convert these into centimetres. I know that we've got 100 centimetres in a metre. So 6 meters by 6 meters is going to be the same as, well, 6 times 100 is 600. So it's going to be 600 centimeters by 600 centimeters. And I'm going to do the same with these. So 10 times 100 is 1,000. So it's going to be 1,000 centimeters by, and 4 meters, 4 times 100 is going to be 400 centimetres. Okay. With this one, the radius of 6 meters, well, we saw up here that 6 meters is going to be 600 centimeters. It means the same thing. And 2 meters by 2 meters, well, 2 times 100, that's going to be 200 centimeters by 200 centimeters. So that's just converting from meters to centimeters. Now what we need to do is to use the scale as well. Now the scale says we've got a scale of 1 to 200 on the centimetre grid. So what that means, every 1 centimetre on our grid is going to be 200 centimetres in real life. Think of it in reverse. Think, well, if we divide this by 200, it's going to tell us how many centimetres we're going to need on our grid. So 600 divided by 200. Oh, I didn't mean to press that twice. Equals 3. So that's going to be 3 boxes, or 3 centimetre squares on our grid. And this one's going to be the same answer, because it's the same number. So it's going to be 3 boxes by 3 boxes. With this one, 1,000 centimetres by 400. So again, we're going to do the 1,000 divided by 200. So it's going to be 5 boxes by 400 divided by 200 is going to be 2 boxes. Okay, well, this is 600 centimetres. We've already seen 600 centimetres, 3 boxes. So the radius is going to be 3 boxes. And here, well, 200 divided by 200, this is going to be 1 box by 1 box. Okay, so we've worked out what we've got to fit on here. Right, this is the space that we've got to fit everything in. Okay, so what do we start with first? So let's go back to what we've worked out. And here we have what we've had. So we've got, in fact, I'm going to write it over here because it'll be clearer. So we've got a 3 by 3 boxes. We've got 5 by 2 boxes. We've got radius of 3 boxes, and that's a semicircle. And then we've got 1 by 1 box. So let's go with the biggest one, which is probably going to be this 5 by 2 boxes. Right, so where can we put that? Well, I'm thinking maybe we put it somewhere out of the way. So let's put it down in a corner. So I'm thinking if we start here, 1, 2 across, 1, 2, 3, 4, 5 up. And notice they've given us 2 grids. We've got practice on this grid, and then we've got another grid down here. So don't worry if you make mistakes on the first one. You're using it to plan. Okay, you've got a chance to do it again afterwards. So 5 by 2. And that was for our swing set, wasn't it? Okay. Then the next biggest thing we had, so we've done this one. It's probably the 3 by 3 boxes for the climbing frame. Well, actually, we've got a nice little corner up here. I mean, it might feel a little bit squished, but we want to make sure we fit everything in. We can always move it afterwards when we've seen exactly how much space we've got. So this is going to be our climbing frame, which is 1, 2, 3 boxes by 1, 2, 3 boxes. All right, we can tick that one off. Then we've got our semicircle with a radius of 3 boxes. Well, if you think it's a radius of 3, well, that means all the way across, it's going to be 6 boxes. So maybe we could have done that one before, because that could be a little bit awkward. So where can we put a nice 6 boxes? Maybe start down in this corner. We'll go 1, 2, 3, 4, 5, 6. The radius is here. So if it's a radius of 3, that means this high point is going to be 1, 2, 3 as well. Now, if you've got a compass, you can use a compass to draw it. Or you can, if you're tidy, you can try and draw a semicircle like that. Okay, that's not too bad, I think. So this was our sand pit, which we can tick off. Then we've got our rockers, 1 box by 1 box, but we have got 2 of them. Okay, well, we can choose where these go. What should we do? Let's put one here. And maybe another one here. Okay, and we'll label these rockers. Okay, so we've got everything on there. When you're looking at it, do put your answer on here because it says put your answer on. You can keep everything as it is because it all fits. If you want to tidy it up a bit and give a little bit more space around the different activities, then fine, but don't waste time on it. If you've got things fitting in, just copy it as it is. That's going to be the quickest way. Okay, question 11. Fundraising. Padma is organising a fundraising event for a charity. The event will include a 3-course meal and a singer. Let's move this up. Padma is working out how much to charge for a ticket to the event. The table shows the costs she expects to have. So the hire of the venue costs £1,660. The meal is £14.25 per person. The fee for the singer is £400, and the other costs are £350. Okay. Padma expects 230 people to attend the event. She wants to make a profit of at least £5,000 to give to the charity. Work out the smallest amount she would charge for a ticket. Give your answer to a suitable degree of accuracy. Okay, so to work out the amount to charge, first of all, we need to work out how much it's going to cost her. Okay, so let's work this all out. Well, the hire of the venue is £1,600. That's just as it is. The meal is £14.25 per person. She's expecting 230. So we're going to multiply that by 230. Which gives £3,277.50. In fact, I'm going to rewrite this over here. So we've got everything together. Then we've got the fee for the singer is £400. I'm just doing it so we can line up the units. Doesn't matter, but just visually might be easier. And other costs are £350. Okay, so the total costs, if we add these all together, are £5,687.50. So these are total costs. But they also want to make at least £5,000 profit to go to charity. So we need to add that in. We're sort of treating that as an extra cost because we need to charge for it. So in other words, from the tickets, they need to make £10,670.50. Okay. And we're hoping to sell 230 tickets. So if we divide it by 230, what do we get? 230. Right, 46.467391. Well, it's money, so normally we'd round it to 2 decimal places, but also it said give your answer to a suitable degree of accuracy. So it just looks a bit weird if you're saying here's an event and you need to pay £46.47p. So we'll round it. So you could round it to the nearest pound or the nearest £10. I'm actually thinking, well, 46 cents. So that would be 0.47. You could round it to the nearest 50p. call it £46.50. You definitely want to round up because they want to make at least £5,000 for charity. You could even charge £47. You could maybe charge £50. Okay, but they would all be sensible amounts. Yeah, any of those. Okay. Oh, and then we can just write our £46.50 on there. Right. 11b. Padma wants to have a number of flyers printed to promote the event. She sees these adverts for 2 printing companies. We've got North Printers, cost 200 flyers for £3.25. Speedy Printers, they get 1,000 flyers for £18. And there's a 12.5% discount on orders over £70. It would cost £97.50 to have flyers printed at North Printers. So this is from these guys. How much would it cost to have the same number of flyers printed at Speedy Printers? Okay, well, we need to work out the cost here, but we don't know how many flyers we've got. So we can work it out from this. Well, if they've charged us £97.50 and it's £3.25 for every 200. Well, how many £3.25s go into £97.50? So 97.5 divided by £3.25 is 30. Now that's not 30 flyers, it's 30 lots of 200. So 30 times 200 means they actually want 6,000 flyers. Right, now we can use this to work out the cost of Speedy Printers. Well, if we want 6,000 flyers, if it's £18 for 1,000, well, for 6,000, it's going to be 6 lots of 18. £108. But we have got a discount. Okay, so we want 12.5% discount. What I'm going to work out the 12.5% first and then take it off. So we want 12.5% of £108. So that's 12.5 out of 100 times 108. Which gives a discount of £13.50. So we take our original 108 minus £13.50, which gives a new total of 94.5, but because it's money, we make it £94.50. How much would it cost to have the same number of flyers printed at Speedy Printers? Well, there it is. We've worked it out. Slightly cheaper. Okay. 11C. At the event, Padma sells 800 raffle tickets for £2 each. Altogether, the people on one table spend £110 on raffle tickets. Padma tells the people on the table, the probability that someone on this table wins the first prize is more than 5%. Is she correct? Okay, let's see. Well, if it's £110 and they're £2 each, 110 divided by 2 will tell us how many raffle tickets they've bought. 55 raffle tickets. Okay. Right, well, we want to work out the probability of them winning from those 55 raffle tickets. Well, it's 55 out of a total of 800. Okay. But we're talking in percentages, so let's multiply by 100 to make it a percent. So 55 divided by 800 times 100 gives us 6.875%, which is more than 5%. So is she correct? Yes. She is correct. Question 12. Eve and Stefan each take part in a quiz every week. They look at their scores in the first 12 weeks that the quiz takes place. Here is a summary of the data for Eve. She got a range of 15 and a mean of 41.25. The frequency table shows the data for Stefan. So we've got this down here. So he got a score of 37 once, score of 38 once, score of 39, 0. So he never got a score of 39, but he did get a score of 40 4 times, and so on. So what's the actual question we've got? So, 12a. Stefan says, my scores were more consistent. Is he correct? Give a reason for your answer. You must show you're working. Right, well, if we're talking about consistency, we want to be looking at the range, because that's how much the scores are varying. Okay, so let's put consistency, and then we're going to do the range, which is the biggest number, which in this case is 43, minus the smallest number, which is 37. So 43 minus 37, we get a range of 6. As you say, I'm going to put up here to summarise our values. Those are Eve's scores. Extend our table. He's got a range of 6. Okay. Now, if we go back to here, Stefan says my scores were more consistent. Is he correct? Well, yes. Give a reason, because his range of values was smaller than Eve's. Then we got part B. Eve says, on average, my scores were higher. Is she correct? Well, looking at average, there is more than one way of working out an average, but for Eve, they've given the mean, 41.25. So we're going to work out the mean for Stefan as well. Well, the mean is worked out by finding the total and dividing by the frequency. So what's the total of the scores? Well, we can't just add up these scores, because 37, yeah, it happened once. 38 happened once. 39 never happened, so we don't want to include 39. And 40 happened 4 times, so we want 4 times this number. So actually what we want, normally I'd do it on the right, but I've written this here now. So we're going to do an extra column, which is score times frequency. Okay, so we're sort of doing right to left. So 37 was scored once, so they got 37. 38 was scored once, so they got 38. 39 was never scored, so we can put a 0 for Stefan for 39. 40 was scored 4 times. Well, 40 times 4 gives us 160. 2 times 41 gives us 82. 42 was never scored, so another 0. And 43 was scored 4 times. So we get 172. So if we add these all up, this is going to be the total scores for Stefan. So 37 plus 38 plus 160 plus 82 plus 172, which gives a total score of 489. So remember, for the mean, we said we wanted that total. And when you divide it by how many there were, well, how many is going to be the total of this frequency. So we had 1 plus another 1 plus 4 plus 2 plus another 4. So 12. So 489 divided by 12 gives 40.75. So that is slightly less than what Eve had. So if we look at that question, Eve says, on average, my scores were higher. Is she correct? Yes. We can say she had a mean of 41.25. Stefan only had 40.75. Okay. So now we just need to find the next question. We've got 12C. In the next quiz, there are 2 multiple choice questions. Each question has 3 options to choose from. Stefan does not know the answers to the questions. He chooses at random an answer to each question. What's the probability that both his answers are correct? Okay, well, if you think of the first question, it's going to be 1 out of 3. And if there's another question, it's going to be 1 out of 3 as well. Now, we need to multiply these together. Okay. The easiest way to think is, well, if you added them together, it wouldn't make sense, because that would give you 2/3. And that would suggest the chance of picking 2 random right answers is more than the chance of picking just 1 random answer. Okay, so rather than thinking, why do we multiply? You can just think, well, it has to be multiplied because it can't be added. So 1 times 1 is 1. 3 times 3 is 9. Now, if you weren't happy with the reasoning I gave, which was a little bit vague, we can think of it more carefully. And we can say, well, let's draw a table. You can get 1, 2, or 3. So 3 possible answers on the first question, and 1, 2, or 3. 3 possible answers on the second question. So that means you could either pick the first and the first answer, the first and the second answer, the first and the third answer, or you might pick the second answer from this question, the first from that question, the second and the second and the third, or you might pick the third answer from the first question with the first answer of the second, the third answer of the first question with the second answer of the second question, or the third answer of the first question with the third answer of the second question. In other words, there's 9 possible answers that you can come up with, or possible combinations, which is the 9 we've got here. If we're completely picking them at random, we're just going to have one of those combinations, which is going to be 1 out of 9. Question 13. Candle company. Maya runs a company that makes and sells candles. The mass of wax in grams needed to make a candle can be worked out using, we've got a formula here, W equals V times, and in brackets, 100 minus F divided by 100 times 0.83. W is the mass of wax in grams. V is the volume of the candle in cubic centimetres. F is the percentage of fragrance in the candle. The company makes a candle in the shape of a cylinder. The candle has a radius 4 centimetres and height of 15 centimetres. The candle has 10% fragrance. Work out the mass of wax in kilograms required to make 2,500 of these candles. Right, we've got 7 marks, loads of work to do. but just split it down into small little chunks. Right, we want the mass of 2,500 candles. Well, let's start off by working out the mass of one candle. And we've got a formula to do it for us. But to use this formula, we need to know what V is, which is the volume of the candle, which we haven't got, and F, which is the percentage of fragrance in the candle. Well, this is the easy bit. So let's do this first. It's got 10% fragrance. So F's just going to be 10. So what we do need to work out is V. And V is the volume of the candle. Okay. So they've told us that the candle is in the shape of a cylinder. So there's our cylinder. It's got a radius of 4 centimeters and a height of 15 centimeters. Now you can use a ruler to make this tidy, but this is just meant to be a sketch. This is to help you to picture things, work them out. If you find it easier to do it all nice and pretty and take your time, that's fine, as long as it's not taking you too long to do. Right, so how do we work out the volume of this? Well, to work out, if it was a cuboid, we'd want the length times the width times the height. But it's not. We've got a circle as our sort of cross section. So what we want for the volume of the cylinder, it's going to be the area of the circle up here times h, or the height. Okay. So the area is going to be pi r squared, where pi is 3.14, r is the radius, which is 4. To square it, we multiply it by itself. So 3.14 times 4 times 4, we've got 50.24 centimeters squared. Okay. Right, now we need to multiply it by the height. So the volume is going to be this 50.24 times the height, which is 15. So that's 753.6 centimetres cubed, or cubic centimetres, depending on how you want to say it. Okay. Now we do need to multiply it by 0.83 to get the mass of the wax. Oh no, sorry. This is V we've worked out, isn't it, the volume? So this is here. Now we need to put the value in the formula. So we can say that W is 753.6 times, and in our brackets we've got 100 minus 10 all over 100, and that is times 0.83. Okay, let's bring this down here. So we'll keep the 753.6. Well, here we've got 100 minus 10, which is 90. I'm going to do this bit as well. So we want 90 divided by 100, which is 0.9. And then we multiply by 0.83. So let's do 753.6 times 0.9 times 0.83, which gives us 562.9392. I'm going to keep all my decimal places for now, okay? Don't want to do any rounding until I've finished that calculation. Okay, and this is the mass in grams, okay? We want the mass in kilograms, but we want that mass of 2,500 of these candles. Okay, so we're going to want to multiply this by 2,500. which is 1,407,348. That is in grams. We want it in kilograms, so we need to divide that by 1,000, because we've got 1,000 grams in a kilogram. And we've got 1,407.348 kilograms. 13B. The company sells large candles for £9.60 each, including 20% VAT. How much VAT is there on each large candle? Okay, so this already includes the 20% VAT. Okay, so we can think of £9.60 represents 120% of the original price, because it's got the original plus the 20% on top. What we want to work out is just the 20%. So what we need to do is divide it by 120. That's going to tell us how much it costs for 1% of the original. And then because we want the VAT, which is 20%, we're then going to multiply it by 20. Okay, so I'll do that in 2 steps, I think. So £9.60 divided by 120. So that's saying it's 0.08 or 8p. In fact, 8p represents 1%. But VAT is 20%, so we want 20 of those, which gives 1.6 or £1.60. And finally, 13C. Katie works for Maya. She has an annual income of 19,410. I'll put commas in. She has a personal allowance of 11,850. She pays 20% tax on the rest of her income. How much income tax should she pay in a year? Right. So this personal allowance means that she doesn't pay any tax on £11,850 of her money. She only pays tax on what's above that. So we want to know what the difference is between these amounts, because she's only going to pay the tax on the amount between 11,850 and 19,410. So let's do 19,410 minus 11,850. Okay, so she's only paying tax on £7,560. Okay, and the amount of tax she's paying, well, she's paying 20% tax of that. So we want 20 over 100 times 7,560, which gives us £1,512, which we can write down here. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, have your notifications turned on to find out when I add more videos, and look forward to seeing you again soon. Thank you.